We're going to talk about the parent functions and then how to identify their transformations, how to graph them, how to write equations from the graph, and just how to identify them in general. Here are our parent functions: the linear, constant, identity, absolute value, quadratic, cubic, square root, cube root, and reciprocal functions. You need to study these. You need to be able to recognize them by their name, their equation, and their graph, so that if I give you an equation, you already know what the graph looks like. If I give you a name, you have a picture of the graph and the equation. If I give you the graph, you're going to be able to give me a name and an equation to match that. The first transformation we're going to talk about are going to be our vertical and horizontal shifts. Vertical would be up-down movements. Horizontal would be left-right movements. Notice the location of this transformation. If I'm given a function, the function plus the value moves it upward. The function minus the value is going to move it downward. In a horizontal shift, notice two things: the location of h, and also pay attention to these signs. If it's inside with the x, minus h is moving it to the right, plus h is going to move it to the left. All right, so let's do some examples. So this first one, we have a parent function of y equals the square root of x. It's a square root parent function. We can find key points by simply finding the square root of several numbers, such as the square root of 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is just square root of 2. Square root of 3 is square root of 3. These points will not be very helpful when graphing. The square root of 4 is 2. So really what we really look at here is we're looking at 0, 1, and 4 simply because those are easy whole numbers. Now, let's look at what that graph looks like. So if I graph this parent function, 0, 0, the square root of 1 is 1, and the square root of 2, 3, 4 is 2, I get a graph that looks like that. Now, if you look back at your the slide that has that library of functions on there, you can see that the square root function is actually the only one that has a real end point on it. In this case, it's 0, 0. Now, what I want to really discuss in this video is actually this idea of what are these transformations? Well, notice it's the square root of x plus 2. That means this g function is going to move the graph up 2. So up 2 means I'm going to take every one of these points and go 1, 2, 1, 2, 1, 2. And so my graph is now here. That new function is there. So plus 2 just moves the graph up. That just means this value of 0 becomes 2. This value of 1 becomes 3, and this value of 2 becomes 4 because I moved everything up. And up is a y value movement. Okay? Now, compare that to this one. This one actually is going to be a left movement because it is x plus 2 inside the square root. That actually means that this point that's at 0, 0 goes left 2. The point that's at 1, 1 goes left 2. And the point that is at 4, 2 goes left 2. So now I have this graph right there that curves. I'm not showing it very good as a curve, but f of x is moved left 2. That means that my points, it's not my y values that are changing, my x values are changing. Okay, so instead of 0, 0, I'm actually going to have negative 2, 0. Instead of 1, 3, I'm actually going to have negative 1, 3. Not negative 1, 3, negative 1, 1. Instead of 4, 2, I'm actually going to have 2, 2 because I moved everything left 2. Let's do another example. So here we have the quadratic parent function, meaning we're going to square everything. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. 4 squared is 16. There's my parent function. So let's graph these. 0, 0, 1, 1, 2, 4. And I don't really have them. Axis of symmetry allows me to come over here and grab these. And so we've already talked about quadratic functions, so we know there's an axis of symmetry there. It's a u, it's a parabola. There's my parent function. So this is y equals x squared. So what happens when we have x squared minus 2? Well, minus 2 moves it down 2. That means each one of these points goes down 2. So it starts here, down 2. Starts here, down 2. Down 2. And so now I have this graph that's been moved down 2. So my x value stays the same, but my y value goes down 2. My x value stays the same, y value goes down 2. X value stays the same, y value goes down 2. X value stays the same, y value goes down 2. You kind of get the idea. Okay? So down 2. So it affects the y. And so what happens here? Well, I've got x minus 2. It's inside the parentheses. That means we're going right 2. So all of my points move right 2. So this one moves right over here. This one moves right over here. And so now I get this graph that's been shifted right 2. And again, we're changing x values there. So instead of 0, 0, I'm at 2, 0. Instead of 1, 1, I'm at 3, 1. Instead of 2, 4, I'm at 4, 4. Instead of 3, 9, I'm at 5, 9. Instead of 4, 16, I'm at 6, 16. So you get the idea. When we're moving left and right, we're affecting the x coordinates. When we're moving up and down, we're affecting the y coordinates. Okay, so let's look at z of x is x plus 1 squared. That makes it a quadratic parent function, which means it's the u. And we're moving this thing horizontally. X plus 1 means we're going to move it left 1. Minus 4 means we're going to move it down 4. So the question becomes, what was the parent function? Well, the parent function is quadratic. Remember, that's 0 squared, 1 squared, 2 squared. And then because it's a parabola, we can reflect it. Here's my parent function. So what does it look like when I move it left 1 and down 4? Whoops, 1, 2, 3. I didn't go down far enough. Hang on. Left 1, down 4. Left 1, down 4. Left 1, down 4. Reflect. And draw your graph. Okay? So last example here. I've got P of x is the absolute value. If you go back and look at your parent function's absolute value is a v. So it's going to look something like this. And x minus 2 means I'm going to move my graph right 2. And x plus 3 means I'm moving up 3. So my point here goes right 2, up 3. My point right here goes right 2, up 3. And I can reflect it. We got one that's going to be right here, right 2, up 3. And I can reflect it. And I'm going to move my V up and to the right.